Welcome everyone, my name is Jen Ziemke. I'm the co-founder of the International Network of Crisis Mappers. It's great to see all of you here. We're going to go ahead and get started. I'd like to thank Curtis and Adil from Oculus GeoTime for hosting these webinars for us. And without further ado, let me first pass it over to Curtis.
Thank you very much, Jen. Hello, everyone. Welcome to the latest series of the CrisisMappers Webinar Series. What I was hoping to do with you folks, for those of you who are this is your first time joining one of the CrisisMappers webinar series, is just to give you guys a little introduction to Oculus, who we are and what we do, and then I'm going to turn it back over to Jen, who's going to take you guys through her presentation today. So, Oculus, we are a company all about data visualization. Our mission is to really try to solve complex data problems through visualization. Some of the different areas that we work in are really areas that have a lot of complex data problems, areas that people need to make decisions with complex data that is very difficult for them to deal with. So, as I said, we try to solve these problems in a visual fashion. Some of the different areas that we work in, defense and government, law enforcement and public safety, as well as finance, all have similar problems with very, very large data sets, complex data that they need to understand to make decisions. Some of the other companies and organizations that we work with, obviously we're all here today to look at some of the stuff that CrisisMappers has been doing, and we're very excited about Jen's presentation coming up. Before we do that, I just wanted to show you guys a little bit about how we like to solve problems here at Oculus. One of the problems that we set out to solve years ago was, how do you look at and analyze movement data, data like GPS data, anything that has places and movement in it? How do you really look at that to do analysis? So what we came up with was kind of a novel way to approach it. We started off by just saying, well, how do we look at that today? And today people look at dots on a map. We look at really those pink dots as places that someone has been, and that's really what we look at to look at movement. This really doesn't show you movement at all, unfortunately. What if we connected the dots together? Well, now we have a path that we can see how the dots are connected together, but it still doesn't really give us movement. It just shows us more order in a very difficult to see fashion. So we came up with this idea of adding a timeline to the map, and this really allowed us to look at movement over time. Here we can see the full 2 years time range of an individual's movement, as well as the location, so we can see both time and space. And this is a product that we call GeoTime. It allows you to see both geospatial and temporal events simultaneously. And this is just some of the ways that GeoTime's been used today. And so yeah, just a little brief highlight of how we try to solve different data problems in a visual fashion. That's all from me. I'm going to turn it back over to Jen Ziemke, who's the co-founder and co-director of CrisisMappers, and she's going to walk you guys through advanced visualization and analysis applied to crisis mapping.
Thank you everyone, and thank you again Curtis and Adil. It's wonderful to be here. As I share my screen and get started, I just wanted to say that I've decided to run a really condensed version of this talk. I'm sort of going to throw a lot at you, but this is the specific idea behind this is that, you know, different folks out there might have different passions with respect to visualization or analysis and different kinds of analysis. And so I think of this as just a conversation or as a dialogue of all the various elements of this that I'm interested in, so that we can foster further collaboration in this space. So I'm a political scientist by training. I'm an assistant professor at John Carroll University and also fellow at Harvard Humanitarian Initiative on crisis mapping and early warning. But what I wanted to share with you today is a bit about my research on the Angolan War. And I've collected about 10,000 battle and massacre events over 41 years of the Angolan Civil War. But I think that what I'm talking about today can really be applied in an exciting way to a lot of the crisis maps that many of you are working on, including, for example, the Libya crisis map or the Syria tracker, certainly the Haiti crisis map. Many of these Ushahidi crowd maps, I think, could be interesting, have interesting kinds of similar puzzles as what I faced when I was working on this project or when I began. And so any kind of map that has location event data or has the desire to sort of put a dot on a map, or concern with perhaps spatial point pattern processes, is part of this conversation that I want to talk about today. And certainly we've learned a lot in the past from our friends in criminology and epidemiology that have for a long time looked at different unique ways to both analyze and visualize space-time discrete event data. What I did during the Angolan, what I did was I was a Peace Corps volunteer on the Angola-Namibia border in the late 1990s at a time when the Angolan War was really experiencing extreme violence against civilians, and sort of some of the things that I saw and heard at that time I didn't really understand, and I sort of felt bad about it because here it is a mile from my house and I don't really understand why this war is happening. I don't have a real way of understanding these events, and I felt sort of bad about not knowing what are the causes of this war, or why exactly am I hearing bombs at night and this kind of thing. And so really I went to grad school as a way of trying to wrap my mind around the Angolan War. And what I ended up doing for my dissertation was collecting archival event data on anything I could find: battles, massacres, troop movements, headquarters, bases, any kind of events of the Angolan War. And some of your work now using digital data, tweets and so on, it could also be related to this. I mean, I think in many ways the data structure is very similar, whether you're doing archival work or if you're collecting something that's digital. But I actually, I'm going to skip forward here, I actually collected lots of articles from 186 different news sources, archival sources. So it's actually photocopies of paper, and they're sitting all here on my office shelf in chronological order. And so I sort of cried after I collected all of this data because it's all in Portuguese, so I had to learn Portuguese just to code it. So I took 2 years just coding and georeferencing all of these papers that I found. And I would code the event, so the battle or the massacre, the time, the place, the location, using a gazetteer, trying to figure out where is Katesh, which one of the many of these villages by the same name is the correct village, etc. And assigning it an actor. So you can see on the right-hand side of the screen, there's many different actors involved in the Angolan War, and we assigned to them either a side A role or a side B role. And this meant that side A meant that you were fighting on the side of the government, and side B meant that you're fighting on the side of the rebels. And I also coded the number of total casualties and the number of civilian casualties and a number of other things. But one of the main important types of variables that I coded was event type. And so I coded the battles and massacres, and there are about 15 different event types, but here are some of the core ones. Whenever a rebel lost a territory or lost a battle and was in retreat, that would receive a certain coding designation. Whenever the government side did this, it would be coded that way. And so sort of just painstakingly by hand, I created this data set that has 9,217 unique events over 41 years. So I really became curious about what explains the variation in civilian targeting. How come, combatants target civilians in a certain time in a certain place, but not in other times? In fact, sometimes combatants go out of their way to sort of avoid deliberate civilian targeting, whereas in other times and places they're in a different situation whereby they deliberately sort of burn a whole village. And it's not a ubiquitous feature in war, certainly, even internal to one war. And I want to understand kind of these variations in space and time and what was the Angolan War from the data that I collected. I need to say that the war is a very complicated one. At its core is a power struggle, a local power struggle between the MPLA incumbent governments and the rebels led by Jonas Savimbi called UNITA. And Jonas Savimbi died in 2002, and that's when the war ended. So it began as a colonial war, a war of independence from Portuguese colonial rule, and but it was also a war that was very much wrapped in both regional and global dynamics, right? There were Cold War actors on the scene. The side that captured power after independence from Portugal, the MPLA, that are the incumbents, they looked toward the east and toward the Soviet Union and had 50,000 Cuban troops supporting them during much of the 80s and some of the 90s, whereas the white apartheid South African regime was fighting on behalf of the UNITA rebels. And indeed, UNITA and the South African Defense Force almost captured Luanda, and if it weren't for the 50,000 Cuban troops protecting the capital city, that might have happened. And so you can imagine there was many other regional dynamics going on in this complicated war, but not to get bogged down too much on this, I wanted to see what one could learn from this data, and as I was coding, I realized that it seemed likely that we would see a trend whereby after rebel side or government side actors lost and were in retreat, they would turn and start killing civilians. And so I thought that the likelihood of violence against civilians would increase in times and places proximate to loss. So that's the core theory I wanted to test. It really didn't honestly come from outer space. It was sort of inductively derived, actually, and this is one of the reasons why I'd like to test this hypothesis on other wars and other conflicts, because just one case where this holds doesn't necessarily mean anything. But I started to notice when I was combing through and during this historiography of an entire 40-year-long war from beginning to end that something was happening even in the newspaper reports, that the reports sounded different. Women, old men, nuns, children specifically targeted, rising rates of torture, mutilation of the dead, sort of ritual sexual mutilation, rape. And there was also a way in which UNITA began to take responsibility for these attacks, where in previous periods they either denied them or said, yes, it was part of collateral damage. And indeed, there was many lists in which Angola was on the genocide watch list. So violence really became catastrophic at certain parts of this war, and even the art of that period, I think, reflects a lot of some of this grotesque brutality that was taking place. And so I didn't really know what to do, to be honest. I had this really complicated event space-time data that had many different variables and attributes. And so the first thought was, okay, well, let's collapse space and at least analyze the variation in time over the 41-year-long period. So I aggregated all the events up into monthly count data for the massacres, the casualties, the losses, etc. And then did a two-step error correction model where I found a very both substantively and statistically significant result, meaning that, for example, in this slide, when rebels are losing in a given month, they are 9 times more likely to commit atrocities against civilians in the next month than they were before, and it's very statistically significant. I also tested this using a zero-inflated negative binomial model and found a similar strong and statistically significant relationship for both the rebel and government actors, robust to changes in this sort of model specification. And so the implications were very strong, and if generalized, one might be able to say then that battlefield and territorial losses are actually an early warning indicator of mass atrocities, that we would expect that as one side or another of a civil war is losing and getting pushed back, and maybe the writing is on the wall that they're reaching their end, that then that's when the warning flag should go up, right? That's when the international community and various groups should expect that the violence against civilians is likely to rise. We can never know for sure, right? This isn't a deterministic model, but just the odds that it might happen would be enough to perhaps suggest policy relevant implications, such as let's open humanitarian corridors, let's do something like this. But I think the core of curiosity is dissatisfaction, right? So even as I'm satisfied with this result, I'm also thinking, well, what's next? Because we haven't looked at the spatial component. And surely, I have space-time data here, and it would be a mistake to ignore that entire dimension. And so I saw that as just a start. And this horrific war has, so many dots on it that when you first sort of open up a map of, okay, let's just look at the number of massacres and perhaps weighted according to the intensity of the event, larger circles are more serious massacres. It still doesn't tell you very much, right? Having all these red dots on a map. And so then you could say, well, what's actually happening underneath this is a lot of events. It's hard to imagine, but they're just stacked up from 1961 to 2002 on top of one another. So you can say, all right, well, what's the number of events at the location? And so for this slide, I want you to realize that this is the points weighted by the number of events. So not the number of casualties, but for the large circles, there's between 101 and 672 unique events or dots underneath that in that space. So this horrific war, people have really suffered so many things. And as a political scientist, we're also asked to test other theories and alternative hypotheses for what might explain the distribution of violence in space-time and this variation. And there's been a lot of discussion about whether countries that are wealthy in natural resources are actually cursed by these natural resources insofar as they often lag on indicators of development or increased likelihood of experiencing civil conflict and war or poor governance. So because of the legacy of this research, I wanted to test whether or not we see any evidence of violence taking place more often in diamond-rich areas versus non-diamond-rich areas. And we can see that the Luanda provinces in the northeast part of Angola, that's really where the core of the diamond deposits are. It's not where the event density suggests the violence has taken place. And even if you measure this using scan statistics, you see that the blue dots are the areas where all things being equal, we're experiencing significantly less risk of violent outbreak at this time than in the red dot areas are where controlling for population, etc., we have extreme high risk of experiencing violent outbreak. Incidentally, some of you might be interested in learning more about scan statistics if you want to test these are tests for spatial clustering created by Martin Kulldorff of Harvard University for epidemiological purposes. I found that his SaTScan scan statistic, which is freely available and online, was an interesting way of testing for either spatial clustering or spatial dispersion that is statistically significant above and beyond the null hypothesis of what we might expect to see, which would be complete spatial randomness, just sort of monkey throwing darts at a board or something. Because sometimes our eyes detect patterns that aren't really there from a statistically significant perspective. And so then, of course, I looked, sort of collapsing the time dimension now, but I looked at, okay, where are the losses and where are the massacres? With respect to the loss hypothesis, we would at least want to see that they were somehow spatially proximate. But again, when you're collapsing 40 years, it doesn't also satisfy one to look at the data in this way. So the data, there's just too much data, it's too difficult to analyze, at least at the point that I was at. This is now 2007 when I was doing this work. And so the temporal domain is collapsed in one case and the spatial domain is collapsed in the other. So I wanted to push ahead and put it into a Google Earth animation with Ola Alkvist of Ohio State University, who helped me with that. but it just looked like a blob of fast-moving dots. When you have 9,217 dots and different kinds of events and different colors of different events, losses and massacres and battles and so on, it was just too much to take in. And so that's when the thank God moment sort of came, when I was connected with the Oculus Geotime folks. And that was the first time that I really honestly saw my own data set. This was the exploratory spatial data analysis. This is what you should do first when you're looking at the data, especially if you're interested in cross-event correlation, especially if you've got complex space-time data. And so for the first time I could see, yes, there's a relationship between my 2 events, which are losses, and my 7 events, which are massacres by the rebels. So it at least looked like in space and time they're proximate. I wasn't sort of inventing this. It wasn't just an artifact of some strange statistics or other maps. And so there's many different ways of examining and looking via geotime one's data set, and really by flying through that and looking, I could also detect other trends and so on in the data that I hadn't seen before and that I was very interested in. So here are just some screenshots. I actually would like to back up to an earlier part of my presentation and just capture a couple of slides that somehow got missed here. This slide. The core of my curiosity has really been, I really just want very much to drill down into the dynamics of violence. I want to treat complex events as complex processes where outcomes are at least partly driven by proximate events and endogenous to conflict. Much of the literature doesn't treat conflict dynamics in this way, so I really want to adopt, I guess, a complex systems level thinking to this approach. And the only way that I'm able to do any of this is really because of help from friends and colleagues. I mean, not one person can't be a linguist and a historian and a conflict specialist, a statistician, and someone that does advanced visualization analysis and machine learning. So we really need each other for these complex problems. And so I will scroll back down to where we left off. I have the sense that conflicts actually move more like wildfires over a landscape. And I've still been frustrated by not being able to sort of see in as many different ways all the complexity of these events. These are stories, these are real life events that are complex, and they're more than just the space and the time and the type. There's the why and the who and the history and the how. And so I want us to think about perhaps some other maps that many of you have worked on in crisis mapping recently. For example, the Libya crisis map. If we could reimagine this map in terms of the crisis dynamics, what could we learn about how that conflict moved? And when I was working with Standby Task Force as a volunteer on the Libya crisis map, and people were asking me what was happening, it was frustrating because I always grabbed a piece of paper and I started drawing. Well, okay, here's essentially what happened, right? Misrata's under siege, you draw a circle around that, and then you'd say, okay, the rebels are roughly in the eastern part of Benghazi, and they're marching towards Tripoli, and they're going back and forth, and there's a stalemate, and so on. And so I found, why is it that we could learn that drawing on a chalkboard was easier than visualizing it and actually looking at, say, the Ushahidi map? You couldn't see that dynamic. And so then I realized, well, the map that you put into a GIS or any kind of visualization platform isn't going to look like wildfire moving unless it's somehow coded correctly. And so I think the main thing that I've realized in the past few months is that I actually haven't coded everything that is important and relevant about these events. There's a lot that you learn that's in your mind. If you read 40 years historiography of a war, you learn how to understand and visualize and make sense of these reports. And so you get a sense of direction and trajectory and link to past events that you wouldn't know. And so I think that we should, as crisis mappers, really seriously consider including some new categories when we're coding these events. So for example, directionality, right? Based on what we know, we have volunteers that, you know, sometimes code for weeks and months straight, and they end up becoming experts of that conflict, or at least knowing sort of the trajectory of events very well. And we would like to preserve that. So in each event, we could have a category that says, this is the direction that this group is headed. We know, because of yesterday's report, that this is the same group that was coming from Benghazi, headed towards Tripoli. We also know, we could say it's linked to past events. Okay, this is the unit whose most previous event was event number 3439, the Battle of Misrata, and now they're headed to Sirte, for example. And we could also subgroup identification. We could say, all right, let's call this A, B, or C unit, or if we know the name that's actually being used on the ground, we could also do that. And so then we could have, you know, maps with arrows and vectors and drawings like perhaps what I would draw just on my own. But I think this is just a start, because there needs to be a way in which we can extract all the complicated nuance from these stories and somehow situate them in their socially constructed milieu, right? So as you start coding a conflict, if you spend 2 years of your life or 2 months of your life doing this, you start realizing, okay, this person said something, but it's not a credible source. Or this might be, we can know for sure a battle took place, but we can't believe that it was 1,000 casualties because this is a mouthpiece of the MPLA, or this is biased toward one side or the other. And so how do we take all that complexity and the knowledge that we learn and filter it into these maps? And these hard problems, I think, really demand collaborative teams, as I've said before. And some of the work that I'm doing is with Artur Dombrowski at Carnegie Mellon University, who's developing some machine learning algorithms to test this loss hypothesis, hopefully, you know, taking full advantage of both the space-time component and also the cross-event correlation that really needs to happen. And hopefully this interface that's developed can be usefully applied and used as well by those of us working in other areas on crisis maps. And I've had this feeling for a long time, though, that you're seeing here, that, and maybe you felt the same way, and that is that sometimes I just feel like I can't see the data set in all its complexity. You want to turn it and spin it and look at it in different ways, in 3 dimensions, in animation. With complex data sets, it's my belief that you need to use as many senses as you have to take advantage of detecting patterns that you might not have seen. So perhaps music, or velocity, or color, direction, texture, all of these elements of our perceptual understanding could help us see complex data sets. And so I think there's a lot that we need going forward, and I'm really encouraged by a lot of different work in this space, by what our friends at GeoTime are doing, and our friends with at Carnegie Mellon, and those of you that might be statisticians that know more about cross-event correlation space-time statistics. It's beyond my reach at that point. I would need help. I would need, you know, statisticians to tell me, yes, this is exactly the kind of model that you need to look at. And it's not about the Angolan War anymore for me. It is, but it's about a broader sense of developing a toolkit that all crisis mappers can use and focus on other fields that have event data that's complicated in space-time. And so along the lines of complex visualization for pattern detection and hypothesis formulation, I'm really, really excited by some of our friends, Dave Warner and Jeff Sale with Synergy Strike Force and the University of California, San Diego, are working on a project with a team of others called Antz. And I really do think that's what's next. And there's some links to their websites here, and so it's free and open source and available. My data set on Angola is on there if you want to take a look at it. And so what this really new and I think fascinating project is trying to do is to convert the complex data that we see perhaps in an Excel spreadsheet or a DBF file into something that's more naturally known by human brains. So the human mind is very good at pattern recognition, right? As my friend Dave has said, we can instantly look out at the world and we can see that's a chair, that's a flower, that's a tulip, that's a tree, that's a person, and I'm sitting in a room giving a webinar and I can situate it in a context. And because the human mind is actually very good at that, why not take advantage of what the human mind is naturally good at and convert our complex data sets into three-dimensional worlds that we can manipulate and turn, and we can actually walk into our data set and we can say, let's look at the data set. Okay, I'm opening my world into this whole new reality which I can spin and I can turn around and I can visualize. And each of these rings can represent different attributes of the data. Why does it have to be a dot? Each color, each shape, each spin or velocity could represent something different, and then we could see something in the data that we hadn't seen before. And so I'm showing you some screenshots from Antz project and from the visualization tool that's been designed. And what's so exciting about it is that you can put your data set in here, and then users can define what color they want each event type to be, what kind of toroid, and you can just experiment and see, what are ways of examining the data that actually allow you to see something new that you wouldn't have seen before. So what I've learned from this Antz work in particular is that I should really test for something that I would have never seen before or never have known, which is it seems that in this work that there's a relationship between different kinds of massacres. So rebel perpetrated massacres and government side perpetrated massacres. It seems like there's almost a tit for tat a competing massacres hypothesis that could be tested for. I would have never seen it had I not played around with this visualization tool, and it's just the beginning of both where this tool is and also my use and other people using it. So it's in a beta kind of version. So I'm really excited about these trends, and I'm incredibly happy to be part of the CrisisMappers Network and the broader community and to engage in these kinds of discussions. I really think that we need to explore more fully how to visualize and understand complex data sets. We're being hit with them more and more all the time. 9,200 events might sound like a lot, but it's going to be small potatoes in an era of digital large data sets with many different variables and attributes, as I've said. And so I think that we need to go far beyond just a cursory examination of event data as dots on a map, but really explore new ways of visualizing and also analyzing and testing hypotheses so that we can really wrap our mind around what exactly is going on, how does this dynamic work? Because if we can better understand, for example, the processes and dynamics of a war, and if it can be generalized to other conflicts, we might really be able to look and say, okay, wow, there's extreme risk to civilians in this period. Let's send someone in to do something about this. And so that's why I'm motivated to find out more. And the humanitarian response that is coded in many of these maps, presence of food and water distribution points, etc., that's also going to, in turn, affect the actual course of conflict itself. So all of these different kinds of events are endogenous to one another. They're part of the same system. It means it's a complex statistical problem in a way, but it's also an exciting journey that I look forward to going on further with you. Look forward to your questions. I know that was very cursory overview, but I just wanted to share with you a little bit about what I've been thinking about, and I'm very thankful for your comments.
All right. If there are no questions there, I'd like to thank Jen for presenting today. So thank you very much, and thank you for all of you who are. Oh, here we go. Here's some questions coming up from Sophia. Sophia asks, I'm wondering how long it took for you to learn the Open Antz platform. Is it for non-technical users? So I guess she's basically asking, what's the learning curve on Open Antz? Jen.
That's a great question. Yeah,
Yep.
Can you hear me? Okay, that's a great question, Sophia, and hello to you. It was easy in the sense that this team was very remarkable. They converted the data set that I had into a data set that could be used in Antz, and then they gave sort of a code book, but it was fairly easy to just open it and start flying around and looking at the data. And then they're really open to feedback as well in terms of how can we make this even more accessible to our users and have this provide more value added. And because I think that, it's exciting to be able to visualize these different things, but you also want to make sure that you're using it in a way to help detect patterns or help see something that you hadn't seen before, rather than just the coolness factor. I mean, at first I just loved the coolness factor of flying around. I felt like I was in my own spaceship flying around through the data, But it's important, I think, to choose the right parameters to take enough time to choose different parameters to get to the point where you're really seeing something new that you hadn't seen before.
I guess she's asking what kind of data set it also takes as well.
So they visualized the Syria tracker data. So any Ushahidi crowd map style event data set where there's a latitude, longitude point, a date, and an event category. They can also handle other kinds of, if you have an intensity score or a duration number, they have a way of capturing lots of different kinds of events. And they're not only looking at crisis mapping data sets, they've evaluated high school test scores and publications, citations, and quality of different kinds of wine and all the different components of wine. I mean, they've done a whole host of different kind of complex data visualization, not just for crisis mapping.
Yeah, I think of. Yep.
Yep, and Eric Frost has mentioned here on the chat window, and I think that's an important point to state, that the Antz developers working in Afghanistan at the moment can really help and run with specific data sets, and they're terrific partners to accomplish things as they develop the program. Well, I really appreciate everybody's time. If you have any further questions or if you want to get in touch for any reason, just send me an email. I'm jen@crisismappers.net. And I'd really like to thank Curtis and Adil for hosting our webinar series, and look forward to seeing you next time.